Greetings everyone. In this video I want to discuss building your own personal server farm. However, with doing that there are a few caveats that need to be considered. So first off, at this point this discussion is purely theoretical. I'm not going to be actually building this for another several months when I get back to the Philippines. This is mainly, right now I'm actually trying to do something different and plan it out before I actually build it, which is somewhat different from me just throwing something on the network and seeing if it works. And I know I specified server in the description, however, I'm going to be spending more time talking about services rather than servers because, well, you can have a server that you can have a computer that runs a server or several servers, but each server runs a service, or it can run several services. So services seem like the more logical approach, since this is all beginning of a plan, theoretical, do I really need a server sort of stuff. Which also I need to discuss server hardware too, so no time like the present to get to it. So one of the first items you should consider is if you actually need a server or not. Do you need specific services? And odds are if you've got a standard network with an internet connection, you probably already have several services running, whether you're aware of them or not. So I'm approaching this from a long-term plan perspective. Again, normally last time I built servers in the Philippines, I just threw them all together to see if they work. I'm trying to take a longer view of this as a plan of attack, so to speak. But, well, back in the old days, we had computers without networks, which everything was standalone. And it was all good. I mean, you could transfer data between computers using floppy disks or what have you. Technically, you could even use serial cables or parallel cables. It just depended on how much programming you wanted to do. Then there were networks. And they were pretty simple networks back in the day, and our computers were peer-to-peer, which means everybody did everything on their own. You could just share data back and forth, and let me tell you, at some point, at some times, there was confusion. And eventually we come to the client server, and the client server, what it allows your computer to do is to log on to the network, get instructions on how to use the network, where the services are, all that kind of fun stuff, and it sort of brings order out of the chaos. I mean, sort of, not always, but that's the general idea. Because we're talking about a client server model, your computer you're using or your device is the client. A server is another computer, whether it's on your local network, out on the internet, it's still a server. I think an example is appropriate here. Let's say, well, you're watching this video. This is coming from a YouTube server located somewhere on the internet. If you digitized all your multimedia films, videos, pictures, audio files, what have you, and then we're getting them from a computer on your local network, that would be a local server. So yeah, local, remote, whatever, they're still servers, they're still providing services. And again, like I said, I need to take a slight detour and talk about server hardware, because if you're going to have servers, you may think you need server hardware. Well, we'll discuss that in a little bit. One of the things I said is you've already got services on your network, more than likely. Depends on your ISP and what other equipment you have. Let me give you a couple of examples here. Back in the day, when I had cable for my internet service provider, they provided a cable modem that was basically cable to Ethernet and nothing else. Being young and bullheaded back in those days, I built my own router out of a laptop with an additional NIC card, so it had two NICs, and it was interesting. It was fun, educational. I do recommend trying it. I don't recommend it for a long-term project as your own router. Well, you can get updates a lot more frequently. Is a pain in the rear to maintain. Now, my current provider in the Philippines, it's a fiber. I'm getting fiber internet, and they gave me an all-in-one. And what I mean by an all-in-one device, you'll often hear them called just plain routers, but it has a modem to convert the optical signals into Ethernet. It has a built-in router with all that functionality. It has a switch. It has a USB port. It has a wireless access point. Again, all in one device. So while there are reasons to not use what your internet service provider provides, how you go about that is, well, like I say, there are reasons. A lot of them are security reasons. We may talk about a couple of them a little later, but yes, you may decide you want your own router, not tied to your ISP, but again, that's your prerogative. Anyway, let's get on with it. And first thing I want to talk about again is server hardware and why you may or may not need it. So that's next on the agenda. Okay, let's go ahead and discuss server hardware. That's always an interesting topic. I've used 3 servers, actual server hardware in my time I've actually owned and used, or had donated and used, what have you. But what I can say about server hardware is it's powerful, ruggedized, fault tolerant, hot swappable, and redundant. Little explanation here. 2 of the servers, the motherboard in them had multiple CPUs. I don't mean multiple CPU cores. I mean it had 2 physical slots for 2 physical CPUs on the motherboard. One CPU could fail and the thing would still keep on running. They all had dual power supplies, meaning one power supply could fail and the thing would keep on running. Lots of drive bays, RAID arrays, dual channel memory. Basically, for the server hardware, like I say, powerful, ruggedized, fault tolerant, etc., etc. You could lose 1 or 2 components and the thing would keep on running. It was a beast, man. However, servers are also expensive, power hungry, they can be loud, and sometimes they're even proprietary. So one of the servers I had was a 2U rack unit. It had some proprietary firmware that required proprietary hardware to run. It actually required that hardware. You couldn't use any open source alternatives. They all had rather small fans as compared to standard desktops nowadays, and they had multiple fans, and when these fans spun up, one of them was medium noise, but the other 2 sounded like jet engines sometimes when those fans spun up. And the other thing is they all used a lot of power. They plug them into the wall and they suck down the amps, suck down the watts. So this brings us back to the question, do you really need server hardware? Now, I can't speak to you, but I can talk about my own case. So let's go a couple things. I do not absolutely require 24/7 or 24 hours a day, 7 days a week, 365 days a year access to all my services. They can be down for a day or 2. It's no big deal. I'm the primary user of the network. If a component fails, it brings the server down. Again, no big deal. I can switch it out. I could rebuild the hard drive in a couple hours, re-download the data from a backup. So again, don't really need the super redundancy, all that stuff. I can stand to have one of my servers down for a day or 2, probably longer. Like I say, I'm the primary user of the network, so these services are mainly geared towards me. But again, I make good backups, and there's nothing really time critical on my network. So no, I don't really need server hardware. Just your standard computer hardware will work fine for what I need to do with it. Okay, let's start talking about services. The first one I want to talk about is file storage. Well, file storage and file management, they're sort of related. How you manage your files that you store. Basically, a file storage service allows you to copy files from your client computer to your computer running the file storage service. Other people can copy files. They can read your files. Again, a centralized location for all your files. It can be very handy, especially if you're working on projects with groups. So, yeah. Now, there are a lot of different protocols, and believe me, there's a wide variation in what you can do for file servers or file services. First protocol I want to mention is File Transfer Protocol, or FTP. This is fairly simple, fairly basic, minimal overhead, but it's also not secure. Don't use this on the internet. In fact, most people recommend not to use FTP on your local network. You may or may not have a choice about that, but is what it is. There is also a secure FTP version. It comes with a little more overhead and encryption. Another file sharing protocol you might be familiar with or need to use is SMB, or this is a Windows protocol. When you share directories on Windows, this is a protocol you're using. I think it's server message block, I think is what it stands for. But yeah, this is basically a Windows protocol. And if you're running Windows computers and you connect to a shared folder somewhere on another computer, this is what you're using. If you're not using Windows computers and you don't need SMB, there's always NFS, or Network File Service, which is Linux Unix protocol, which is not natively supported by Windows. But again, there are choices, and these are just a couple. There are many more choices. There's things like WebDAV, and well, when you start thinking about what you want to do with a file service, then you can start thinking about what protocol you need to use with it anyway. But again, basically simple. Laptops, computers, whatever devices are the clients. You have a centralized computer that stores your files, and that's file services. Management comes in, and well, it's not very fun if two people try to open the same file or delete the same file or anything like that. So there is some management, also some security considerations if you want everybody to have access to every file. FTP doesn't really give you anything in that regard, but SMB and NFS do, as well as local permissions on the computer running the file service. But yeah, that's file management, file service, file storage. That's probably one of the main ones people are going to use regardless of what other services they use. This next one's kind of a biggie for a lot of people, and that's a media service. Basic purpose of media service is to stream media from your computer that's hosting a service to your client. There's also functionality in there called transcoding, where if, for example, you have a TV that has a 1080p maximum resolution, but your files are 4K, you may need to transcode them down to show up on the TV. Files are stored either on the computer running the media service. They can be on a separate computer. Generally, media services also have some sort of database connectivity to track your files, keep track of where you are and watching them or listening to them. But yeah, media service is something a lot of people want on their network. Some common ones are Plex, Jellyfin, and Mini DLNA. There's also a sort of one called Apache. I don't include Kodi in this list because Kodi really isn't a media server. It's more of a standalone or a client unit, depending on how you're setting it up, but it's not really a media server, so it doesn't fit into this category. But yeah, media service pulls files from your file storage. If they need transcoding, it transcodes them and then sends them to the device that's receiving and displaying them. Pretty straightforward. All right, the next one I want to talk about here are virtual private networks. And generally, this is better described as a service available. It's on a computer on your network someplace. There's a lot of information on the internet out there about how good or how bad or how non-consequential VPNs are, or virtual private networks. There is one use case where you might want to have one on your network. And if you're like me, with my ISP or internet service provider in the Philippines, they've got me behind CGNAT, or carrier grade network address translation. This is also in your router, but you can butts with it in your router to get packets in and out. If it's at the ISP, yeah, you can't touch it and you can't get in from outside your network. That's a good thing for protection, but if you want to access services inside your network, you need to get around that. The way you do that is with a VPN. You have a computer running a VPN inside your network, talking to a computer running a VPN somewhere outside your network. It could be at a friend's house. It could be on a hosting provider. A lot of possibilities here. It could be a provider like Cloudflare. But basically what it does is the VPN, the client inside your network, it sends packets, empty packets, to the VPN outside your network. Because with CGNAT, you can send packets out and it expects a response back. Therefore, the VPN can send packets back into the VPN inside your network. And if you connect to the VPN from outside, you can then load your data into its packets and exchange it inside your network. And then from there, you can get it to an actual service inside your network. This is definitely a use for a VPN that is kind of important if you need services accessed outside of your local network. Okay, I don't want to get into a big discussion on all the different types of services, so we're going to run through some more of them pretty quickly. A gaming service, again, multiplayer games hosted on your own computer. You don't need an internet connection. You can control who's playing on it, have better access to resources. Minecraft's the one that comes to mind, but there are lots of others that you can host locally. Cloud services, this is like Dropbox or Google Drives or OneDrive, but you can host your own on your network. This goes back to file storage. The cloud service is basically an interface, usually through your browser, to get to your file service or your file storage service. And it generally has other functions. Nextcloud is an example of this. You can do your files. It has a media player you can add as a plugin. It has calendar. It has contacts. Again, it could do everything for you that a lot of the Google services do, but you host it locally on your network. Backup services. That's another important one. I always have a backup service running on my network. Usually I use rsync, but there are other programs out there that do it too. I like back up my servers at night, usually starting at like midnight or 1 o'clock. It depends. It's usually a cron job to run the backup. The initial backups you do are going to be kind of extensive. Incremental backups after that will be pretty quick. Firewall, that's something that may be a service built into your router, but again, if it's a standard consumer grade router, the firewall is probably fairly minimal, and you might want something a little more robust. So you might want to run your own firewall. AdSync, that's another fun one. When you go to a lot of these sites, they have ads all over the pages. These ads aren't coming from that site. What is on the site is links to ad servers. And AdSync, again, a prime example is Pi-hole. It will look at the addresses that is coming over the web page. If it's coming from an ad server, well, it goes to null or into the bit bucket or whatever you want to call it, and not to your page. And again, like I say, Pi-hole is a prime example. Database service, again, dynamic web pages require databases. A lot of cloud services require databases, so you may or may not want to have a separate database service running on its own computer, or it will be embedded with other services. Applications, think Microsoft 365, online word processing, online other applications. Collaborate Office is the big one in the shareware community, which you can run your own office on the separate computer and everybody can access it. In fact, you can access documents together at the same time, do group editing. Web server, Apache, Nginx, what have you. There's a lot of them out there. If you want to host your own web pages, your own wiki, you will need a web server or web service of some sort on one of your computers. Proxies are another one you might want to throw into your network. These sit between your computer and something else. There's proxy and reverse proxy, but these are basically an added layer of protection. Mail, this is a tough one. I've run mail servers in the past. At this current time, with the state of email, I will probably never run another email service. I mean, they can be a little tricky to set up and maintain, but the problem is once your address you're using gets out to the spammers, you'll get flooded, and then you're the one who has to sort through all that stuff. Whereas if you have a separate mail service, they can do a lot of that for you. Getting down here towards the end of my list of other services, DNS caching. A DNS is usually used to take your human readable web address and convert it into an IP address out on the internet someplace. DNS cache remembers every place you've been, and if you check the cache before you go to a remote DNS server, it will speed up your browsing immensely because you've already cached that data. It's quicker to get it off your network than to get it off of a remote DNS server. Domain name service is DNS. Dynamic host control protocol is another one. This one's probably handled by your router. One of the problems with having it handled by routers, especially consumer grade routers, they don't get that many updates, security or otherwise. You could actually take a separate computer, as long as you got a couple of NICs in it, network interfaces. You could build your own, or you could actually run pfSense or IPFire or something like that, and basically have your own router, do your own DHCP, all that separate from whatever your ISP provided. And NAT, Network Address Translation, that sort of goes in the same basket with DHCP. Many cases, you'll probably just want to let the whatever router you have handle that. But again, consumer routers don't get that many updates. There's a security issue. As long as you're staying on your local network, that's really not much of a problem. But if you got things coming in from outside, it could become an issue. Anyways, those are just some other services to think about that you may want to run. Okay, I've mentioned ISP router several times, so let me jump into Internet Service Provider router. My current router is a multifunctional device, so it's first and foremost, it's a fiber modem that translates the fiber signal coming into Ethernet. It also includes a router which does all the DHCP, NAT, that kind of stuff, has a firewall. It also has a 4-port switch on the back. Additionally, on my router for the Philippines here, it has a phone jack on the back for where you can plug a regular phone into if you get that service from the ISP. It also has a USB port where you can actually plug in an external storage drive. This could be your file storage on the network. This one, I believe, uses FTP. And like I said, I get the fiber coming in, and it's also got a wireless access point. So I got a couple of antennas sticking off it, but that's, like I say, it's a general all-in-one system. And of course, you've got your personal computers on the network or other devices. They could be phones, they could be tablets, they could be whatever. That's part of your network. If you start thinking about it, especially if you have people over, there's a lot more devices than you're probably expecting. I know a lot of times when people come over to our house in the Philippines, they've got their laptops, they've got their phones, some of them have tablets. And nowadays you can get toasters that are connected to your network. Washing machines, dryers, refrigerators, everything. You can have a lot of stuff connected up. And then you have your servers. And again, whatever your servers are doing, whatever services they're providing, it is what it is. That's another component of your network. And like I said, I mentioned before, a computer can run a single server, it can run multiple servers, and your servers can run a single service, or they can run multiple services. So what it really comes down to is figuring out what services you want to run, how many servers you need to run them, that sort of thing. But start with the services you need. You don't need to set up a whole bunch of servers and find out, yeah, they're all not really running very well, or they're all underutilized. That's the term I want to make. They're all underutilized. So again, your whole network, your ISP provided all-in-one, your personal computers, your servers, other people's computers, home automation, security systems. I'm going through all this because the last thing I want to talk about is what my network used to look like. And it may look similar, it may look a lot different with this new project, but I had my fiber line coming into my ISP all-in-one, and interestingly, the ISPs all-in-one had some built-in nerfs in it. It wasn't hard to crack the ISP password and unnerf the thing, but it had it built in. So for example, one of the switch ports was turned off. Anyways, from my router, I hook my personal computer directly in, landline, hardwired. That's the best way to connect to your personal computer. It gives you the most resources. Then another port went to a switch, which was divided up amongst my server farm. When I was running it before, I had a Pi 3B, a NUC 8th generation, and a Series 8 Max from B-Link. Those were all basically micro single board computers that made up my server farm. Then the last port went to another switch, which went out to everything in the house, the wireless access points, which I needed because my house in the Philippines is made out of cement. So yeah, you really need to spread out those wireless access points. The CCTV system, home automation, miscellaneous, and all that. So yeah, that is what I had. I don't know if that's what I'm going to have. It'll probably be close, but it won't be exact. All right, that's about it for this video. I talked about all the various services I'm going to want to run. There are others out there I didn't mention that you might want to run, but I'll leave that up to you to research them. Again, as I'm saying, I'm going to try and make a list of services I want to run, figure out how much computational power, how much memory, hard drive space they're going to need, and then from there determine how many servers I actually want to install on my network and how I want to put them together. In the past incarnation, I did use Proxmox for about 6 months because, yeah, I said I didn't like Proxmox the first time I used it, but I said I got to give it a fair chance. So sort of like I'm running Fedora right now for 6-7 months just to give it a fair chance and get a decent amount of experience with it. But if I don't do Proxmox, I'm probably thinking of going with the Cockpit for a GUI server management sort of thing. We'll see how that goes. But I welcome any suggestions, any comments, anybody with some great ideas on how to go about some of this stuff. There is some basic stuff I need to talk about. We'll talk about in future videos. One of them is going to be power requirements. I've got a single dual outlet hooked up to a 15 amp breaker, which is hooked up to one of the bedrooms. Luckily, it's a 220 volt system, so it's a higher wattage that you can draw out of that. But yeah, I need to distribute that between all the equipment, so I'll have to be doing some sort of power management. My servers, since they're micro PCs, are probably going to continue to be that, are going to sit on a shelf. I need to organize the cable, so I'm going to need some sort of cable raceways or cable trays underneath the shelves. It's just little things like that you got to think about. I'll be talking about these, but I'll be glad when I can actually get into the Philippines and actually start working on some of this stuff. But again, like I say, anybody's got any ideas, let me know. Anybody's got any thoughts? Also, if you like this video, please like, comment, subscribe. It all helps out. Anyway, we'll see you next time.